I'm not actually here to introduce Iron Raw, but I had to add something because when I first saw this guy, he was the badass of atheism. He really, excuse me, is that all right, Aaron? Badass of atheism? He basically said it as it is. No bullshit. It was right on. Everything he said to me made sense. And he's not afraid to denounce religion. It was only 3 years ago that he started going out. The first trip that he did was invited to Darwin Day down at James Randi JREF organization, or was the conference down there?
Darwin Day.
But if you've ever seen him on YouTube, he's really great. And I saw him in person at the Reason Rally, which we're going to play a little clip of a little bit later. But he had fun with the Christians. There was a small crowd of Christians there with the big band. There was about 8 or 10 of them. And when this guy showed up, the video cameras came out because everybody knew what was about to happen. And during his 10-minute spiel with the Christian, you could see the wheels turning in this guy's eyes just because of this gentleman. Here's the person who's going to be introducing Aaron Brown, Laura Brown Linder. Come on up, Laura.
And he is also the producer, director, writer, author of just a wonderful, wonderful series. If you haven't seen it, you've got to see it. It's The Foundational Falsehoods of Creationism, and it's been seen by millions of people worldwide. Most of his videos focus on biogenetics. Please help me introduce
How do you get this to show just the main slide? I don't know how at all.
I think it's the play button in the top left there.
Yeah, F5.
All right. And yeah, I think so. Yeah, that's much better. Okay, seriously, play. Oh.
Oh, hey.
Yeah, I didn't expect that. And is that right?
It is.
Okay. All right, well, I have a peculiar interest, as you mentioned, in phylogenetics, in the systematic classification of life. I like to see how everything fits in a cladogram. Just as it is important to know what time it is, or what month it is, or whether Columbus was born before or after the fall of the Roman Empire, or that it's important to know what states or countries are on your borders in all directions. Things most people should know and a lot of people don't. I think it's important to know where we are geographically, chronologically, historically, and phylogenetically. So just as a cartographer wants to improve the accuracy of his maps, I want to chart the phylogenetic tree of life through all its descendant branches. It's interesting discussing phylogeny with creationists, because how do you argue that we didn't come from apes if we're still apes? And likewise, birds are dinosaurs in exactly the same way that lions are cats, and iguanas are lizards, and whales are mammals, and all for the same reason. It might surprise some of you to find out that we are monkeys, too. And what's funny about that is that a lot of people don't realize, or the more educated you are in this, the more wrong that claim seems to be. Scientists who are well versed in this subject, I hope this works, not quite as the way I wanted it to. Scientists who are well versed in this will say that we did not come from monkeys, that we share a common ancestor with monkeys, but that our ancestors were never monkeys themselves. They'll admit that we are apes, which we used to deny until recently. but we've been taught since childhood that apes are not monkeys. And that only an ignorant person would look at a chimpanzee or a gorilla and call that a monkey. That's what I said myself until recently. And the problem is, and people who understand this will tell you that, monkeys as we traditionally recognize them are divided into two groups. There's the Old World monkeys and the New World monkeys. The New World monkeys are the ones with the prehensile tails. The Old World monkeys have tails that are weak, diminished, or absent altogether. There are a lot of other important distinctions. These are just the most obvious ones. Another would be that nostrils for the New World monkeys tend to display in opposite directions, where the nostrils of Old World monkeys are parallel and usually point down. Other people that know this subject fairly well and would contest me on this will position, or that will say, that all the Old World monkeys that are traditionally monkeys in the traditional sense in the Old World are limited to circipeds, because all the ones that still exist happen to belong to this group. But these are not the only Old World monkeys that have ever lived, and apes are not a sister clade to monkeys. They're actually a subset of monkeys. And this isn't just according to their collective traits, but also because they were labeled as monkeys. The fossil precursors were labeled as monkeys by leading specialists in paleoprimatology. Specifically, they refer to Proconsul as a monkey-like ape, and to Aegyptopithecus as an ape-like monkey. So the common ancestor of all Cercopithecoidea and Hominoidea was an Old World monkey from a now paraphyletic grouping called Propliopithecoidea. Now, a polyphyletic taxon is when two lineages, or when the same lineage evolves twice, independently, such as if monkeys were never our ancestors, then monkeys are polyphyletic, meaning both groups of monkeys evolved from a common ancestor that was not a monkey itself. It's like in the old sci-fi movies where you have human beings evolving on different planets unrelated to each other. That doesn't happen in real life. Now, scientists who recognize that and are still determined not to admit that our ancestors were monkeys will sometimes say that the Cercopiths are not monkeys either. I've actually seen cladograms listing New World monkeys and Old World primates. And they do this knowing that we've always recognized the Old World monkeys as monkeys before we even knew the New World monkeys even existed. But, as I say, there's another group, a fossil group, paraphyletic group, that most people are not aware of because it's paraphyletic, and that's why it's out. I'll explain that in a moment. And the ancestors of the New World and Old World monkeys collectively are monkeys also, this time from a paraphyletic grouping called Parapithecidae. Now, a paraphyletic grouping is an antiquated, outdated concept or convention that arbitrarily excludes certain descendants for no defensible reason. Now, this can be helpful in identifying evolutionary stages, as I've just demonstrated, but it has no practical value in systematics. This convention implies that our ancestors stopped being monkeys the moment they became apes. And the problem is with the Linnaean definitions. If you're going to classify any collective, you must define its members according to the total tally of traits unique to that category and already shared by every member, universally accepted as one among them, without making special exceptions for certain ones. The criteria has to be consistent if we were to determine for certain whether a new addition belongs in that set or not. And bear in mind about the Linnaean definitions of monkeys that there are many commonly accepted monkeys, like macaques, for example, do not have tails. Now, it is impossible to list the characters common to all monkeys inclusively without describing people too. And this is especially so when you refine the category to any of the simian subsets in our lineage. If you describe the characters for monkeys in general, or more specifically Old World monkeys, or more specifically apes, or more specifically great apes, if the parent category, or if it is a parent category that includes us, then those characters will describe us too. So we didn't stop being monkeys the moment we became people either. Now, I didn't come here to tell you that you're all a bunch of monkeys. In the real world, this information isn't very useful. My point is to get you to understand the difference between paraphyletic and monophyletic classification. A monophyletic taxon, also known as a clade, is one which includes all its descendants. And it isn't necessarily based on the characters currently expressed. Rather, a monophyletic classification is based on an organism's evident phylogeny. It's based on evolution, because of the simple rule that you cannot grow out of your own ancestry. One of the criteria, or the part of the human condition, is that we have 2 arms, 2 eyes, 2 legs, above average intelligence, and so on. But if you're born without any or all of these traits, you're still human, because your parents were human. You can't grow out of your own ancestry. So if your grandparents were mammals, then your grandchildren will be mammals, even if some of them are born completely hairless. In an evolutionary phylogeny, monophyly is the only system that works because, and this is important, evolution never suggests, nor permits, that one thing ever turned into another fundamentally different thing, despite what all the creationists want to say about that. Anybody who tells you otherwise is misrepresenting the facts, either through ignorance or malice. Evolution is never more than a change in proportion, be it anatomical or biochemical. Unique mutations may emerge in a single individual, but it doesn't become evolution unless it is inherited by subsequent generations and spread through a network of descendants until those traits become common throughout the population. So that, remember that evolution is defined summarily as descent with inherent modification. So every new species or genus, etc., that ever evolved was just a modified version of whatever its ancestors were, as illustrated here. So that evolution at every level was just a matter of incremental, superficial changes being slowly compiled atop successive tiers of fundamental similarities, which represent taxonomic clades. The problem with paraphyletic terms is that they're dependent on characters that are currently expressed. And even then, they're neither inclusive nor consistent. Take, for example, the words fish and reptile. These are paraphyletic terms with no application in taxonomy. In the old Aristotelian concept, we evolved from fish to become amphibians and then reptiles before we turned into mammals. And this would be true if we used those definitions. But we can't, because those definitions don't really work. For example, fish does not have a consistent definition of traits universally applicable to everything accepted as a fish. There are some that have lungs, or that have legs instead of fins. There are some that don't have scales, or have black fins on their tails. And there are some things that are very much like fish, but aren't fish, yet they have gills. And then looking at the amphibian, if we propose that an amphibian is the intermediate stage between them and reptiles, at what point does an amphibian stop being a fish? The only way that the word fish could be considered useful in taxonomy is if it were synonymous with the word chordate. However, all of us are chordates, and some of you, I'm betting, will argue that we are not fish. The definition of, or the old Linnaean definition of reptiles, I need to mention something about the amphibians too. They were never an intermediate stage for amphibians. Our ancestors were never amphibians. It's kind of like, well, the class Amphibia is a sister clade to class Reptilia, in the old terms. It's kind of like the order Carnivora for mammals. It includes dogs, cats, bears, hyenas, seals, weasels, and so on. There are many other animals, including reptiles, that are carnivorous, but are not members of Carnivora. They're not carnivores, and carnivore is not exclusively carnivorous either. So while the intermediate stages, and there's quite a lot of them, we've actually discovered a wealth of intermediate stages between fish and mammals in particular, but none of them were technically amphibians. They were a sister group. They branched off separately. Now, the Linnaean definition of reptile is a scaly, clawed, cold-blooded, egg-laying amnion. By that definition, our ancestors were once reptiles. But not all reptiles have scales, or claws, or arms or legs. Some of them give birth live, and some of them lead to warm-blooded descendants like mammals and dinosaurs. So we needed to have a definition that takes evolution into account because these characters change. Okay. Now, if you're going to adhere to the law of monophyletic hierarchy, then you can't define reptile as as a synonym for amniote, because mammals are amniotes too, and these groups diverged very early on. Thus it was decided that if we are to give the word reptile a meaning that is consistent with a cladistic evolutionary hierarchy, then it would be synonymous with diapsids. It no longer matters if they're four-legged or cold-blooded. The definitive characteristic is the emergence of these two temporal fenestra, the holes in the skull. One of them closed again in ichthyosaurs and plesiosaurs. Doesn't matter, they're descended from those that had to. And both of them closed later on in some, though not all, birds. Now, if you're having some difficulty visualizing or conceptualizing birds as a subset of reptiles, look at it this way. Sorry, that slide doesn't. Look at that one. That one works much better. Okay, this on the top left is Dermesia limus. It means an emu mimic, and you can see the rendering without the feathers of what an emu actually is. I had one of these as a pet. This does not look like a substantial increase in genetic information to me, despite what the creationists say about the transition from dinosaurs to birds. This looks like a drastic reduction of information to me. And we now know that many of the dromaeosaurs had feathers, including Velociraptor. And how does this affect your interpretation of Jurassic Park? But remember also that herpetology is the study of reptiles. And some states actually require that you have a herpetology license in order to keep certain exotic birds. So that's just one way to look at it. Now, the reptilian class, or the diapsid class, more properly known, they are the same thing, splits into two groups, archosaurs and lepidosaurs. Today we know them as crocodilians on one side and lizards on the other, but both groups used to be a whole lot more. And I'm going to focus just on archosaurs for the moment. People often ask me why the dinosaurs all died out and everything else survived. Well, first off, the dinosaurs didn't all die out. Birds are the last remaining dinosaurs. And secondly, it's not like everything else survived. Dinosaurs represent hundreds of known species of archosaurs, but there were several other subsets of archosaurs that are all wiped out completely. Pterosaurs, for example, once hugely diverse. They're actually older than dinosaurs, probably more successful than dinosaurs in that respect, and much more diverse than this image implies. I couldn't find an image that adequately rendered the diversity of pterosaurs. We have one, for example, that they don't know if it could fly anymore because it was as big as a giraffe and apparently lived like one. Literally. So anyway, the only remaining archosaurs, apart from birds, are a handful of crocodilians. And they used to be much more diverse, too. This one, as you can see, is on its way to becoming an ichthyosaur of sorts, though it can't because it's on the wrong line. Now, what most people know about fossil paleofauna is limited to a few plastic pieces in a prehistoric clay set. They have no idea of the volume of diversity that's revealed in the fossil record. There were way more genera that have gone extinct than man has ever seen alive. For example, every bird that currently exists falls into one of two groups, Paleognathes and Neognathes. And you can see by the Paleognathes, you can guess which one. I didn't have to put the labels on. They're the ones that are reminiscent of old-fashioned dinosaurs. But there used to be a few other groups that are no longer represented at all. We only know about them through the fossil record. And curiously, this group does not include Archaeopteryx. There are many taxonomist systematists now who consider that Archaeopteryx was very close to the origin of birds, but was not ancestral to birds and should not be considered a true bird itself. Skeletally, it is more similar to a non-avian dinosaur called Coelophysis. So there goes another creationist argument about whether we had flying dinosaurs. Likewise, mammals exist. All the mammals you've ever seen fall into three classifications: eutherians, marsupials, and monotremes being the most primitive. But there used to be twice as many categories as there are now, and there are no survivors from any of these other sets. Nor are there any survivors from any of the precursors, the therapsid, mammal-like reptiles. Once upon a time, a hugely diverse and wildly distinct group, which is now not represented at all anymore, except by the few true mammals that we still have remaining. Now, on the Lepidosaur side of the reptile family tree, all that are left from all that used to be there are lizards, and that's it, with one singular exception, the Tuatara, the little guy over here on the right. is the last remaining sphenodon. It, just like Archaeopteryx is an almost but not quite bird, the Tuatara is an almost but not quite lizard. And snakes, in case you're wondering, actually are lizards. Not to confuse you, but there are legless lizards that are not snakes. Snakes are highly derived. As a matter of fact, they are the most derived, most diverse, the most reptilian species on the planet today, and yet the Bible calls them cursed. So from the dawn of all animals, we have the emergence of synapsid, therapsids with one temporal fenestra, and the divergence of diapsids with two temporal fenestra. And we have a host of pre-reptiles, para-reptiles, called anapsids with no temporal fenestra. Now bear in mind that from the synapsids, every mammal you've ever seen and all their immediate ancestors are in that group. All the actual reptiles that have ever lived, including birds, are in the diapsid group. And similarly, the anapsid group once represented a hugely diverse field of animals which are now survived by only a single lineage. A few months ago, I endured a 4-hour interview with Pastor Bob Anyard of Denver Bible Church. During his radio show, Real Science Friday, he hit me with this challenge. It is not enough to tell him that we found potential or probable ancestors for turtles. And it's not enough to show them to him. This was an opportunity to explain to him the overlapping sciences involved in how phylogenies are investigated. He wasn't interested in any of that, but perhaps he might be, so I'll tell you what I told him. Turtles are a really old group, but they didn't just come out of nowhere. There are precursors, but they have precise criteria required to identify potential ancestors or transitional species. The fossil record reveals that at the time that turtles emerged, there were a great plethora of anapsid proto-reptiles, which is another thing that creationism cannot explain. And that most of these died out in the greatest or the worst extinction level event in geologic history. Approximately 187 million years before the demise of the dinosaurs, there was another calamity called the Great Dying, in which 96% of all marine species and 70% of all terrestrial species were wiped out in a series of calamities associated with or attributed to climate change. If there is a single catalyst for this devastating conclusion, it is yet to be positively determined. But that's a speech for another time. Our ancestral turtle would have to be an earlier, more generalized anapsid, but one which shares special affinity with turtles. Fossil record reveals a number of closely allied stem groups that share these tendencies. Perhaps a Pterosaur that is too turtleish to deny, but which still has undifferentiated turtle characteristics, such as teeth. Real turtles don't have teeth anymore, except in movies. Apart from that, our ancestral turtle would look very much like a turtle, albeit without a shell. Or, to better identify its lineage, it would have not enough of a shell to qualify as a true turtle yet. I remember, as I said, in the 9th foundational falsehood of creationism, the anapsid clade once included turtles on the half shell, or with no shell at all. Turtle shells have two main components, the plastron and the carapace. The former is conjoined ventral plates, such are found on the sternum and pelvis of the Permian para-reptilian macroleader. In turtles, these would be fused into a keratinized matrix, a mixture of bone and shell. If that is the first testudine adaptation, then our ancestral turtle, the oldest turtle we've ever found, would be, let's see if I can remember this guy's name, Odonochelys cividistacia, the oldest turtle we've ever found, and yes, he still has teeth. Now, either this animal developed the plastron first, which is possible, or it begins a new line in which they have lost the top half of the shell. The top half of the shell is made out of two layers. They're osteoderm scutes overlaid on a framework of extra wide, broad-bladed ribs. Now, both of these are dramatic adaptations, and so they likely would not have occurred simultaneously. So we're looking for an earlier anapsid that has either enveloping osteodermal armor or broad-bladed ribs. And again, the fossil record provides both. Some pterosaurs and para-reptilian dianectids showed a propensity for both ventral plates and enveloping osteodermal armor. If this combination is the first tested on trait, then our earliest turtle ancestor moves to Chimelicheles tenatester from about 210 million years ago. That's that one. Now, although this is obviously a turtle, it's incomplete. Its shell is very thin, the thinnest ever found. And it's consistent with an evolutionary procession and not consistent with an intelligent designer who had any idea what he was trying to make. Otherwise, he would have made that, not that. Chimelicheles is regarded as a turtle in progress because its ribs haven't fused to the shell the way they have in all other turtles known to date. Evidently, when turtle shells evolved, you have the osteodermal plates first fused to each other, and then to the spine, and then to the ribs, which hasn't yet happened in him. However, embryological development tends to parallel evolutionary development, leading to a field of science called evo-devo, which has proven to be very helpful in charting evolutionary trends. Turtle embryos broaden their ribs as the first stage of shell development. If this is the first tested on trait, then according to the most recent computer analysis of morphological traits, the closest proposed common ancestor yet known for all turtles is a not yet turtle called Untitled. Oddly enough, this animal was once dismissed from the turtle lineage because of the conviction some scientists had that turtles had to be true reptiles. The position of turtles within amniotes is said to be one of the oldest and most contentious controversies in vertebrate systematics. Genetic tests show them being closer to lizards than to crocodiles, but we don't have any of the DNA for uncontested parareptiles, and you can't triangulate their position without that. So paleontologist Tyler Lyson and his team reanalyzed a recent data set that allied turtles with the lizard Tuatara clade and integrated physical characteristics of earlier anapsids for physical analysis. They found that the inclusion of stem turtle, Progonicheles quinstetti, and the parareptile Untisaurus africanus results in a single overriding morphological signal with turtles outside Diapsida. That means turtles are not true reptiles. None of these species are supposed, the way creationists would have you believe. They are all factual, and each shows concordant stages in turtle evolution. I could get into the details, but I've already bored most of you, so I'm not going to. The only contention there, even if they didn't represent turtle evolution, immediately adjacent to them is Milleretta, which also shows dermal scutes, broadening ribs, and propensity for dermal scutes all at the same time. So it may be an unresolved position as to whether turtles lie within Diapsida or basal to it, but we have all the essential characters emerging in all the closely associated taxa. So the systematists at paleos.org concur with the peer-reviewed Tree of Life project that turtles, testudines, are a eureptilian precursor to diapsids, not a subsequent subset. Now, the point I wanted to make with this talk was to give examples of evolutionary controversies, actual evolutionary controversies, scientists arguing over how evolution happened. But of course, there's no argument over if evolution happened. That hasn't been for 150 years. Most of the data I've just shown was discovered only in the last 20 or 30 years or so this was harder to explain when I was a boy, but it only gets more and more obvious. There is no reason why a god would specially create a turtle with a haphazardly conceived and incompletely constructed shell. There is no reason why a miraculous conjurer would have to make the shell out of the animal's ribs. I don't know, maybe God just likes making stuff out of ribs. There is no reason why a benevolent deity would have caused waves of extinction level events in all these animals incapable of sin, and do it repeatedly, wasting every successive explosion of biodiversity. And there is no reason that a creator of different kinds would have left behind such an obvious trail of apparently sequential transitions. Experiments in trial and error are not indicative of any infallible architect. These are implications of incidental rather than intelligent design. And drawing it back to our own species, to what I said before about primates and the law of monophyletic hierarchy, leads me to one question that I have for these contentious creationists. If I can get that last slide to work. If we didn't come from monkeys, then why are we still monkeys? Thank you.
We're going to have 2 to 3 quick questions. I see somebody's aiming for the microphone right now. 2 or 3 questions.
I don't know if it's easy to get back to the first slide, the circle diagram.
That is a
Explain what that
genetic,
is.
yes, we have, well, that's on Mac, I don't know. Yeah, don't laugh at me, please. Or laugh later. That chart at the beginning it's a phylogenetic chart done by a computer using the integrated genomes of 3,000 known species. And it's just 3,000, but you see how intricate that is. And that was a computer design. They have computers that also analyze for physical characteristics, and these two can often overlap, and usually they will. Very rarely when you get a genetic mapping like this, do you find any discrepancies. There are some interesting exceptions, and I made videos about a couple of them. But this is what we're aiming for in phylogenetics. We're looking for genetics to provide the confirmation of what we were talking about. Like I said, where we don't have definitive proof in some cases, where we lack the genome, but we have the physical characteristics. The physical characteristics are the paternity test for evolutionary trends. Does that answer your question?
Yes, thank you.
And no one else. Good, I'm gone.
We're going to take about a 10-minute break and come on back.